Okay, and we're back. So, after some time, it's been around like 2 hours or so, I came up with a solution. I had to do some math, and um, what's going on here? Let me just quickly check. Yeah. So, what is the solution when we are trying to multiplicate? Um, it's not that difficult, really, but when we are trying to multiplicate everything, mm, we need to do, first of all, we need to think about the sizes of not metrics we're working with, but we need to think about the sizes of the metrics that we are going to get. Okay, so what does that mean? And here, our k is going to be the number of lines, the number of the elements in each line in our new matrix, which is going to be the biggest of the previous ones, basically the number of columns in the first matrix, I guess. M is going to be the same, right? Which is going to be equal to the number of elements, the number of elements in one line in the second matrix. And in this case, I guess, I do really hope that we will be able to do it greatly. I checked it really quick, but not with all the possible matrices. And and here we need to multiplicate what? We need to add so many times how many elements there are in the one line in the first matrix. So how many columns are there in the first matrix? If it's true, then we just do it. And pay attention to the indexes. You see? So this should never go out of I. It never should extend the number of columns in the first matrix, right? So after that we print the result. And I was also saying that we can multiply a matrix to a number. How do we realize that, you may ask? So if everything is okay and we can like multiply those numbers with this, but how do we define a single number? Very simple. It's going to be a matrix with one line and one column. And if it is so, we just multiply each of the elements of the first matrix to this number and then print it down. It's pretty easy. The first thing, I also altered a little bit this part when we were filling the matrices. You see, the previous code lagged a lot. So what basically we are doing? We input it. If it's done, it's true, we can print it. You can delete this part, doesn't really matter. But if it's not done, if we are still if it's a new line, so we split this line, we make a new variable, and for each element in the list of things we made. We make it, we turn it into integer, and we also add it to our m line, right? And when the m line is formed, we add it to our matrix. So now it all works. Also, to make sure that we are able to do multiple operations with one and the same set of matrices we've already entered, so not to waste the time, I wrapped all the further code into the while true, so that it's going to work infinitely unless we are interrupted. So now I guess that we can check it. In here, I checked it on this variant, but not on this variant. So let me show how it works, right? It's going to be 4, 2, 3, 1, 1, 5, 1, 2, 2, 3, 1, 1. Okay. 4. I had it. 4, 2, enter. 3, 1, enter. 1, 5, enter. Done. We have the first matrix. 1, 2, 2, enter. 3, 1, 1, enter. Done. What would we like to do? We do not match them with the sizes for any addition or substitution, so we will do the multiplication. And then the result is going to be 3 tens, 677, 1677. Let's look at the result here. 3 tens, 677, 1677. I haven't tested it with this set, so basically the same matrices but in the different direction. Now let's do that. It's gonna be it's gonna be 1, 2, 2, 3, 1, 1. Done. 4, 2, 3, 1, 1, 5. Done. Multiplication, the moment of truth. Oh, it really worked. 12, 14, 16, 12. 12, 14, 16, yeah. Wow, I did it. I really did it. Huh, interesting. Okay, now let's think of some multiplication to just a singular number. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's gonna be 2, just 2, nothing else. Multiplication. 2, 4, 6, 8, well, yeah, but basically each number multiplied to 2. So as you see, it works. Now, when it comes to addition and substitution, we need the matrices of the same sizes, right? So let's do it. Like 1, 1, 1, 2, 2, 2, 3, 3, 3. This is gonna be our first matrix. And the next one is gonna be 3, 3, 3, 2, 2, 2, 1, 1, 1. Addition, all fours, of course. Substitution, negatives a little bit, and that's understandable. And multiplication, yeah. Yeah, as you see, it all works. I hope so, at least. Let's check it also at the bigger matrices, not 3 to 3, but like mm, 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 mm. I like quadratic. Oh no 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 no! It's not gonna work like that. Addition. The sizes do not match. What? Ah. Can we do at least the multiplication though? Yeah, okay. So yeah, it works. Just the first matrix I entered was basically 4 to 3, not 4 to 4 as the second one. So yeah, addition and substitution wouldn't work with these particular ones, but all in all it works. Just look at that monster. That's a monstrous code, really. And when it comes for so many different cycles to make up new lists, we can really shorten it. We can shorten it a lot with list comprehension. Basically, what is list comprehension? List comprehension is a special syntaxis that allows us to shorten the generation of lists that are made by some cycles, right? Basically, what it is, it's or equal to. Now we need an element. And what we're going to do with this element? Elements, I don't know, to the power of 3, 4, for what we are going to do. For elements in, and here we have an iterable, but we don't have an iterable here, so it's going to be range. Range 4, and then print war. Oh, hello, hello, yeah, 1, 0, yeah, 0 to the power of 4 is 0, 1 to the power of 4 is 1, 16, because 2 to the power of 4 is 16, and 81, as 3 to the power of 4 is 81. And make sure that everything starts with 0, okay? So yeah, and like this we can do lots. For example, if we have a list here, just a random list, like let it be like this, okay? And in here we do not say or in range, we say in li, in a variable containing something iterable. And here we are. 1 to the power of 4 is 1, 4 to the power of 4 is 256, and so on. You see, it works. This is a very powerful tool. We need, well, I need to train my habit to use it, because basically, especially when we're talking about matrices, I'm so bad in math that I don't really think that it would be a good idea to practice something you well bad. So I'll take some time to practice it, just for me not to think about how it works. It's a pretty new trick for me. I've never really used it yet, but who knows? Maybe I will. So thank you very much. That's it for matrices. It's been a long way. And next program is going to be very simple, but I'll do it in a separate video. It's going to be simple database with the data of the students, and we need to do it using dictionaries. I don't really think it's going to be difficult or complicated in any way. So yeah, but number 10 is going to be tough though. I guess pretty much like this one. And after that, we will talk about functions. So, thank you very much for coming to see this video. Hope you enjoyed it. Hope you understood everything. And keep pushing. Have a nice day. Bye.